In permutation and combination problems, we are interested in selecting a certain number of objects from a set and determining how many ways that we can select those objects. In permutations, we are looking at a distinct ordering or arrangement of the objects. This is quite different in the combination problems where we're simply looking at the objects as a group with no order or arrangement. Distinguishing whether you have a permutation or a combination problem is the biggest trick in solving these problems. The math work is not that difficult. Another item that helps me determine what type of problem I need occasionally is that I remember for the same set size and the same number of objects that we're selecting, you're always going to have many more permutations than you do combinations. Okay, how do we calculate permutations? You can see in my Word diagram or my Word document that's shown in this video, I have an equation and we use the nomenclature P parenthesis N comma R. N is the total number of objects in the set and R is the number that we're selecting, and we calculate permutations as N factorial divided by the quantity N minus R factorial. Most of you already know that factorial means something special. I'll give you an example. 3 factorial is equal to 3 times 2 times 1. 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. One other note, we also express P parenthesis N comma R in another fashion, and this shows up on your calculator if you happen to have a TI Texas Instruments calculator. We write lowercase n, uppercase P, lowercase r. And if you have a PRB button, it stands for probability. If you have that on your calculator, you probably don't have to do any of the math work that I'm going to show how to do in just a couple of minutes. So let's jump in and do a permutation problem. First of all, we've been asked how many ways can 3 objects A, B, and C, be arranged? Now, the key that this is a permutation problem is that the word arranged even appeared in the problem. That's not always going to happen, but it did in this one. And yes, when they say the way objects can be arranged, it's implied there's a sense of ordering that's important, and that's what clues us that it's a permutation problem. Okay, well, I just did some little work ahead of time here, and what I've done is written down using a systematic approach every combination that can be made using the letters A, B, and C. And how many did I get? 1, 2, 3, 4, 5, 6 of them. There are 6 ways that 3 letters can be arranged. Now let's calculate this using the formula that we have. Okay, so first we need to determine N and R. N is equal to the total number of objects in the set, and we have 3 objects in our set, so N is 3. And what's R? R is the number of objects we're going to select, and in this case, we're selecting 3. So we are looking for P 3, 3. Or sometimes they'll say permutation 3 select 3. And that is equal to n factorial, n is 3, 3 factorial over the quantity n minus r, or 3 minus 3 factorial. Now let's see, that's 3 factorial over 3 minus 3 is 0. And we know that division by 0 is a no-no, but what we haven't, or what we probably remember, is that 0 factorial is equal to 1. It's a special case, and so what do we have? Anything over 1 is just the numerator, so we have 3 factorial, which is 3 times 2 times 1, or 6. And there's our answer confirmed. Number of permutations in 3 select 3 is 6. Okay, let's go on and look at another example. What if, let's see, we have, let's say, how many ways can two objects be arranged with set size of 4? So in this case, let's write it out. Let's be good here. 4, question mark. Let's say we have A, B, C, and D. And what we want to do is, from our set of 4, select 2 objects. Now, do we have a permutation problem or a combination problem? Once again, the word arranged was used. So the order that the objects are going to be selected is important. In that case, we're looking at a permutation. Let's do the math here. 4 select 2. Our equation says we need n factorial, which is 4 factorial, divided by the quantity n minus r. Oopsie. 4 minus 2 factorial. And that means 4 factorial. 4 minus 2 is 2 factorial. And now I'm going to write out factorials. This is 4 times 3 times 2 times 1 divided by 2 times 1. And now, since all objects in both the numerator and denominator are multiplied together, we can cancel top and bottom. So the 1's go away, the 2's go away, and we are left with 4 times 3, or 12. There are 12 different ways that 2 objects can be selected from the set of A, B, C, D. 12 ways that 2 objects can be selected from that set. Let's see, one of them is AB, and another one is BA. Now those are the same letters, but they are 2 different permutations.